For this lesson, I want to focus in on the Sprite class and creating the Sprite class that we'll put in our game engine code. If you look on the course website, I've provided you with the skeleton for the Sprite class, and that'll give you all of this code. And let's just fill in the details now to make that work. So first of all, let's deal with the constructor of the Sprite class. The Sprite class constructor is taking two arguments, the x and the y location of the sprite when it gets constructed, and we'll just put that into the position. So it's going to be x position set as x and y position set as y. All right, now beyond setting the position of the sprite, we also need to make sure that we take care of setting the shapes for the sprite. Sort of. In the Sprite class, we're defining a public abstract method, define sprite, and we're going to use that method here in the constructor to define the sprite. So the sprite shape will be equal to the result of the method define sprite. And you might say to me, how can we use a method that doesn't have any code? This public abstract method doesn't have any code in it, so how can we use that? When we declare a method as abstract, what we are saying is it is the subclass responsibility to take care of declaring and overriding that method and adding code to it. So programs won't be able to directly make instances of our Sprite class, but they will be able to create any instance of a subclass of the Sprite class that will then have the responsibility of adding the define sprite method. Okay, we'll see that in the next video when we use this class to create the ball for our game. And I'm also doing the same thing with the hitbox. So the hitbox is going to be equal to the result of the method define hitbox. Again, that's an abstract method whose job it is to return the shape for the hitbox of the sprite. All right, other than that, we're pretty much done. The Sprite class extends group in JavaFX so that we can create something that we see on the screen. And we need to make sure that all the parts of the sprite that we want to see on screen are actually placed on screen. So that's what I'm going to do next. I'm going to go this.getChildren dot add all. And the number one thing that I would want to see on screen, of course, is the sprite. Every once in a while, for debugging purposes, I might want to be able to see the hitbox. And I've actually added a few other properties as well. A circle to show where the center of the sprite is located. And that circle is always going to be located at the coordinate point 0, 0 of the group. The shape that makes up the sprite could surround that. Like, for example, for the soccer ball, I'm trying to put 0, 0 at the center of the soccer ball. But that just means that part of the ball itself will be in the negative coordinate locations and part of the ball will be in the positive coordinate locations. And that's no problem. So again, for debugging purposes, once in a while, it might be handy to be able to actually see that center. And as I'm trying to debug physics, I've made a line to show what the velocity of the ball is. And I'm going to add that as well, the velocity vector. Now, to get the velocity vector to sit in the right place and actually to set up all of the debugging view of the sprite, first of all, I've created a Boolean property called physics view, and normally that's going to be set to false. I don't want to be in physics view normally. But to see these things when somebody sets physics view to true, I'm going to bind a few properties so that if I go set physics view to true, it basically puts me in a debug mode and I can see the stuff that I want to see. So what I'm going to do is say for the hitbox, I want to take the visible property and I want to bind that to the physics view property. And that's already typed in for me by Eclipse, right? If the physics view is set to false, I won't see the hitbox. And if the physics view gets set to true, I will see the hitbox, right? I'm going to do the same thing with the center. Visible property. I'm going to bind that to the physics view. And I'm going to take the velocity vector, which is a line, and I'm going to set its visible property. I'll spell that right, visible property, and I'm going to bind that to the physics view as well. Right, so now I've got it set up so that if I change the physics view from false to true, I'll automatically see all the little debugging parts. There's one last thing with the velocity vector. I want the start of the vector to be located at the coordinate 0, 0, because that's the center of my sprite, no matter what I do, no matter where I lay it out. It's the point that the whole sprite is going to move by. But I want the other end of it to be bound by the velocity in the x direction and the velocity in the y direction. So I'm going to say velocity vector dot end x property, and I'm going to bind that to x velocity, and velocity vector end y property there we go. I wondered why it wasn't popping up. I had a little bit of a spelling mistake there. And y property, and I'm going to bind that to the y velocity. Right, that'll make my velocity vector look right anytime I'm looking at the physics view of the shape. Now with the physics view, if I have the hitbox visible, I probably won't be able to see the sprite anyway. And so I might even consider saying, okay, in physics view, I'm going to take the sprite and bind its visible property to the physics view, but I don't want the normal physics view. I want the not version of the physics view. If physics view is false, I see the sprite. And if I set physics view to true, I stop seeing the sprite and I just see the hitbox, the center, and the velocity vector. And that, oh, there's one more piece of setup that I need to do for making sure that the group stays at the location where it's supposed to stay. And that is to say this dot, the layout x property is going to be bound, so bind to the x position, and this dot layout y property is going to be bound to the y position. After I do that, when I say to create the soccer ball at, for example, 100, 100, this group will be laid out with the 0, 0 center point of the soccer ball sitting at 100, 100 on the screen. Remember, there's a slight difference between coordinates on screen and coordinates within the group itself. All right, there's my constructor code. You can pause the video and copy that if you need. I don't have to put any code in this class for these two abstract methods, the define sprite and the define hitbox. Now, let's talk about how we can tell if one sprite is touching another sprite. First of all, I want to make some guard statements here. If this sprite's hitbox is null. If this sprite doesn't have a hitbox, there's no collision, so we can return false. If the sprite that's being passed to me as an argument, that sprite, if that sprite's hitbox is null, I can return false, that they don't collide, because there's no hitbox to collide with. Beyond that, what I want to do is to take the hitbox of this sprite and intersect it with the hitbox of that sprite. So I'll make a shape. I'm going to call that my test area and say that the test area is equal to capital S shape, because I want the shape class, which provides the intersect method. It allows me to intersect this hitbox with that hitbox. And if there is any intersection in that, then I can say return my test area dot get bounds. It doesn't really matter if I say get bounds in local or get bounds in parent. I'm just going to use the local. Get bounds in local, and I'll check the width of that sprite of that boundaries box. If the width of that boundaries box is not -1, not equal to -1, then the sprites are touching and there's a bit of overlap. If the width of that boundaries box is -1, that means that there was no test area, and that would mean that I should be returning false. If it's equal to -1, I should return false. If it's not equal to -1, the two shapes are touching, and I should return true. So my return statement there will work, as long as I fix up what's the problem with width. Oh yeah, not width, but get width. All right, so there's a sort of quick and dirty test to see if the two sprites are touching by combining their hitboxes. One thing that I can do to kind of speed up these tests is I can add to this a few little checks beforehand to see if it's even necessary to go checking out the intersection of the two shapes. Remember, doing the intersection of two shapes, that's a bit of a slow operation. If I could find out the answer here faster, that might be a good thing. And in order to check the answer a little bit quicker, what I could do is look at the bounding box around the hitbox for this sprite and the bounding box around the hitbox for that sprite, and just test to see a little bit if there's even any chance that those two bounding boxes could overlap. So what I'm going to do is declare a bounds area. I'll call it this bounds, and that's going to be equal to the hitbox for this sprite. I'll be explicit and say that this dot hitbox dot get bounds. Now this time I have to say that I want the boundaries in the parent. If I say local, then I'm dealing with the boundary box that's centered on 0, 0 for both of them, and they probably will overlap. I don't want that. I want to test screen coordinates here. So get the boundaries in the parent for this. And I'm going to do bounds for that sprite is equal to that dot hitbox dot get bounds in the parent. Okay, and now I can do a couple of tests to see if the boundary box for this sprite even could possibly overlap the boundary box for that sprite. And what those tests look like, they're going to be something like this. If this bounds dot the minimum y, get minimum y. So that's the top of the boundary box for this sprite. If that is greater than that sprite's boundary box, that bounds dot get maximum y. So if the lowest possible y value for the boundary box of this sprite is lower than the maximum possible y value of that sprite, then one sprite is completely above the other and they can't possibly be touching each other. And so I could return false. Right, and I can write that again in the other way if see if that sprite is completely below this sprite. So I would do that as this dot bounds dot get maximum y. So if the bottom of this sprite is less than that dot bounds dot get minimum y, they're not touching each other. If this sprite is completely above that sprite, they can't be touching. So that's above and below. And now I can test left and right. If this bounds get maximum x, so if the right side of this sprite is less than that bounds dot get minimum x, if the right side of this sprite is to the left of the left side of that sprite, they don't overlap. There's no way. And I can just return false. And one more test here. If this bounds dot get minimum x, all right, so that is going to be the left side of this sprite, and if that is bigger than that bounds dot get maximum x, so the right side of that sprite, they don't overlap. All right, so hopefully that can just make our routine for checking for collisions just a little bit more efficient by seeing if there's even a possibility of a collision before we do the slow stuff to see if there's a collision. All right, if I'm commenting this, no hitbox, no collision. The second part here is check if it's even possible for there to be a collision. If it's possible, actually check to see if there's a detailed collision. All right, so pause the video there, add that code if you need. For some of the rebounding physics that I might try within my game, it might actually be nice to know what is the area where the collision happens with the sprites. And for this, I just want to return that intersected area. I'm just going to copy that and paste it there for the return. All right, now the last part that we have to add some code to is how to update this sprite when the animation time happens. So when the animation timer goes off in our program, it's going to tell us that a very small amount of time has passed, something like maybe 0.05 seconds. That would be the elapsed time. And the question is, how far should the sprite move in that amount of elapsed time? Well, I have the velocity for that, right? Remember, distance is equal to velocity times time, right? So the x position is going to change. So I want to go x position dot set, and I should set it to whatever the x position was. So x position dot get, and then I should add to that the x velocity dot get times however much time has elapsed, and I'm being passed that value as a parameter, elapsed time. Right, so just basic physics equation there. The new position is equal to the old position plus velocity times time. That's all that is. And we do it in the x direction and the y direction. We're going to need y position dot get plus y velocity dot get times elapsed time. And just noticing a spelling mistake on velocity there. There we go. And that's all I have to do. That's all I have to do to update the position of the group, because remember, the actual position of the group on screen is bound to my x position property and my y position property. So when I change those variables by setting them, automatically the group will have its position updated. Right? The other code that is in the skeleton code that I provided to you in the course site has the getter and setter methods for changing the x location directly and changing the x and y velocities directly, and just for looking to see what those values are. You'll also notice that I have a method to set the physics view to true or false. I have a method to see what the physics view is, and I'm actually exposing that whole property, the Boolean property for the physics view, in case I wanted to do something really crazy like bind the physics view to a toggle switch in my user interface. I could do that. Right? I'm not making the x position and y position properties exposed visibly outside of the class like I did with the physics view, because I don't want people to be able to bind to the position or velocity locations. I want them to change them only through getter and setter methods. And that should handle everything that we need for the generic Sprite class.